Good morning.
Good morning.
Holy cow, where is everybody?
Basketball.
I didn't get a single email about that. Okay, let's see who's here. All right. Okay, Andres is not here.
No, I'm here.
Oh, you are?
Yeah,
Where
right
are
here.
you? I just can't see you.
Oh,
Okay, there you are.
okay.
I moved the self view. Thank you. All right, Desiree. Naomi. Raylyn. Caitlin.
I'm here.
Avery. Cyrus. Tara. Jay. Lauren.
Here.
Taylor. Ricky. Seth. Madison. Kinsley.
Here.
Sierra.
Here.
Hannah.
Here.
Let's see, was Sierra there?
Here.
Okay, thank you. Jocelyn. Cottrell. Rebecca. Serena. And Anna Marie. Okay, so present, I have Hannah, Sierra, Kinsley, Lauren, Caitlin, Andres. Did I miss anybody? Okay. All right. Well, let's see. Let me calculate something here. Let's see. 25th, 26th. 1, 2, 3, 4. Okay, so you guys help me make a decision here. Basically, we're normally I would not teach anything new with so many people absent. I kind of have a personal rule that says I got to have at least 50% of my students to cover anything new. And so my first impulse would be to, see if there's any Moodle tests or anything that you guys need, any tests or quizzes to make up. However, right now if I were to not cover anything new today, I would worry about, I would probably have to rush because right now we're exactly at the number, maybe a half a day. But I don't really, if I were to not cover anything new today, I would be worried about pushing it a little bit, and maybe I can do that. So what do you think? What do you guys think would be better for the class, to not cover anything new or to maybe push a couple of lessons quickly? Anyone have an opinion?
I think for the class it would be better to not start anything new just because we have so many people missing.
Okay, all right. Well, I'll tell you what I'm gonna do is, any other discussion?
I personally would like to do some stuff today just so I don't feel like I have to cram for the rest of the semester.
Okay.
We don't have that much time left, but I do feel for all the people that are missing that are going to have to make stuff.
That's true. That's true. Hopefully, see, the way that I have it before just to let you know, the way I count it is I have 5.5 lessons of new material. And I have 6 days before the final exam. So that's kind of where I'm at. All right. So, well, any other, because I guess I could just say, well, watch the video. All right. And so then everybody can see it. But anyone else want to weigh in before I make the final decision here? All right. Well, I think what I'm going to do is, I forgot about the video. I think I'm going to go ahead and teach, and but I kind of don't. Well, anyway, if I had another day to give up, I probably would. But it's not like some classes where because I feel like I do have to prepare you for the final and make sure we go over everything. So. Anyway, do we all have the 4.5? Yes? Okay. All right. Well, let's go ahead and do that. And
We don't have 4.5.
you don't
Yes.
have 4.5?
No,
And Mrs. Smith isn't there, is she?
no, she's not there.
And she's not going to be there tomorrow either.
I think.
So all right.
So,
Okay, so I'll tell you what, you guys that don't have it, I'm going to go ahead and post it on the Moodle. And for right now, if you want to just, write down the blanks or whatever on a sheet of paper, and then you can just kind of see. I mean, I don't what? Go ahead.
if you send it to me, is there a way like I can print it off real quick?
Yeah. I'm going to post it to the Moodle, and then if you want to print it off, then you can do that too. Okay. All right. Okay, so it's on the Moodle at the very bottom of chapter 4. Okay. All right. So in the meantime, let's just go ahead and start on this. I put it right here at the bottom. Okay. Yeah, now that I think about it, somebody did say something about a basketball tournament this week. I think maybe Avery did. So anyway, well, let's go through this. Okay, so this is the last section in 4.5, and we're talking about graphing rational functions, working with asymptotes. Okay, and so it says the domain of a rational function of x includes all real numbers except whatever makes the denominator equal to 0. So if you're ever asked about the domain, basically you look at what values for x will make it go to 0. To find the domain of a rational function of x, you set the denominator equal to 0 and solve. And so the domain would be all real numbers except the zeros of the denominator. So whatever makes the denominator go to 0, you throw that out. Okay? All right. So here it says find the domain and the equations for the vertical asymptotes of the function. Okay, so let's just start with the domain. So what values for x would make the denominator go to 0?
Positive or -3.
Right. So then you would say the domain is all real numbers except those. Let's see, do I have that? Whoops. Okay, so that's the domain. All right, next we want to talk about what that causes to happen in the graph. All right, so where you exclude those values, that's where you get a vertical asymptote. Okay, so a vertical asymptote, remember, is not the graph of, it's not technically part of the graph. It just helps you know where the graph is. So like here, if I have a vertical asymptote at 5, because 5 would give me a 0 in the denominator, then you draw your vertical asymptote, x equals 5. Now the equation of a vertical line is always x equals. So that's the equation of a vertical asymptote, is always x equals. And so that's where the graph can't cross. Okay? So there's different behaviors around the vertical asymptotes. Both sides of the graph could go up, could go down, one side up, one side down. Just depends on the equation. Okay? All right, now, so x equals a constant is a vertical asymptote. Y equals a constant is a horizontal asymptote. And so that's a horizontal line that helps us graph the function. So if we know where the horizontal asymptote is, again, it's a dotted line and it's not part of the graph. Okay, then what we call oblique or slant asymptotes, so that go off at an angle, those can also help us graph the line. And so we'll learn how to find those. Now, just a little thing about notation here is that when we use this little arrow, that means x approaches. And so if you see a plus or a minus after the number, then that means x is approaching from the left or from the right. So this would mean x is approaching 3 from the right, or the plus side of 3. This one means x is approaching 2 from the left, so from the left, the negative side of 2. Okay? And so just so that you understand the notation a little bit. All right, so here, again, the little arrowhead, you read that as approaches. So 2 with a little minus, that means what's going on as x is approaching 2 from the left. So in this graph, as x is approaching 2 from the left, the y value is going down to negative infinity. Okay? Where is, let's see, no, that's a different thing. Okay, So going back to our practice problem, where it says find the domain and the equations for the vertical asymptotes. The vertical asymptotes are those same values that are excluded from the domain. And you put the x equals in front. That's important. Okay. So x equals. And then x equals plus or minus 3. So then when you're doing the graph, before you actually start graphing the function, you graph those vertical asymptotes. So x equals 3, x equals negative 3. Okay? And so that's not the graph. That's just the guidelines to kind of help you know where it goes. Okay. All right. So the notation f of x approaches 5 as x approaches infinity means that the y value approaches 5 as x approaches infinity. So as x goes out farther and farther to the right, what's the y value doing? Is the function going up? Is it going down? Values for which a rational function is undefined but cancel with common factors in the numerator result in a whole. So not everything that has a 0 in the denominator is going to be a vertical asymptote. Because, like for this one, see how you have, when you factor this denominator, you get x plus 2x minus 2. So then this x minus 2 and x minus 2, that factor would cancel. So what that means is at x equals 2, you wouldn't, right here on the graph, you wouldn't get a vertical asymptote. Instead, you'd have a hole in the graph. So if the factor could cancel, the canceling factors produce the holes, not vertical asymptotes. All right, so if you're asked to find the vertical asymptotes, then what you need to do is factor. Factor the numerator, factor the denominator. Okay? So in this, the denominator has two factors, x plus 5 and x minus 3. So you wouldn't say that they'll both produce a vertical asymptote because the x minus 3 will cancel with that one. And so just kind of looking at it in factored form, see, the x minus 3s would not be a vertical asymptote. Instead, you'd have a hole there at x equals 3. So a hole at x equals 3, your only vertical asymptote would be at x equals negative 5. Okay? So a hole at, so be like, so like over here someplace, you'd have a vertical asymptote at x equals negative 5. So vertical asymptote at x equals negative 5 because of this factor. The hole is the factor that cancels at x equals 3. Okay? All right, so see if you can do practice 2. Find the domain, the vertical asymptotes, and then if there's a hole, find that too. What's the x value for the hole? All right, so Kinsley, what is the numerator a factor to?
The numerator factors to x and then x minus 1. Or can it also be x plus 1, x minus 1?
No, because if it was x squared minus 1.
Oh, okay, gotcha.
But x squared minus x is what you said the first time.
Okay.
X times x minus 1. Okay. All right, so the domain is all real numbers except 1. Okay, because 1 would give you a 0 in the denominator. Okay, so at x equals 1, are you going to have a whole or a vertical asymptote? So do this if you think it's going to be a whole. Do this if you think it's a vertical asymptote at x equals 1. Okay, you're right. It's a whole because it has a factor that cancels. Okay? So when you go to graph it, it's actually the same graph as y equals x. But at x equals 1, you would have a whole. Okay? So there's no vertical asymptote here. So y equals x, that's the graph y equals x. But just when x is 1 on the graph, you put a hole right there in the graph. Okay? Okay, so this is actually the big deal for this section because we've actually talked about vertical asymptotes a little bit before. But horizontal asymptotes, this is the part that not only do you need to know it now, but this will help you immensely in calculus if you can remember this part. Okay? And it has to do with finding a horizontal asymptote or oblique asymptote. What you do is you compare, you have your polynomials in descending order. And then what you do is you compare the powers. So like in this one, it's x to the 5th plus blah, blah, blah. Because you don't even care about the rest. X to the 3rd plus blah, blah, blah. You just look at the leading terms. You compare the exponents. Okay? All right, so it says if n is greater than m, so in other words, if the denominator wins, the horizontal asymptote is y equals 0. If n equals m, so the powers tie, the horizontal asymptote is a over b, where a and b are the leading coefficients. Okay? So the horizontal asymptotes you do in your head. You just look at it and say, boom, there it is. Okay? So when it ever asks for a horizontal asymptote, with a little practice, you'll love those problems because they will just take you literally a second to do. You just look at it. Now, the ones that, if n is greater than m, so if the power is bigger in the numerator, like this example here, then those are the ones that are going to take the time. Because here, then that means it has no horizontal asymptote. Instead, it's a slant or oblique asymptote. And the way you do those is by polynomial division. I don't know if you can read this. It says, here, these you do in your head. This you do by polynomial division. And if the numerator, like here where the numerator is greater than m plus 1, so that means it's more than one term, it's more than one bigger, then there is no linear slant asymptote, which is mostly what we're going to have in this class. So typically the questions for these will just say find all the asymptotes and wholes. So to find the vertical asymptotes, you did what we did on the last one, whereas you factor, cancel, see what makes the denominator go to 0. To find the horizontal or slant asymptotes, you compare the powers. You do this right here. Okay? Okay, so let's give you an example here. Okay? So let's say I wanted to know what's the horizontal asymptote for this. Okay? So what you do, again, you compare the powers. So 2 and 2. So when they tie, the horizontal asymptote is y equals a over b. So in this case, it would be 1 over 1. So the horizontal asymptote would be y equals 1. Okay? Now remember, a horizontal asymptote is going to have for its equation y equals. A vertical asymptote will be x equals. Okay? All right, so let me just show you if, when you're comparing, if the numerator wins, so the higher power is in the numerator, then that's when you have a slant asymptote. And so there you go through and you do your polynomial division, except when you're writing your slant asymptote, it's just the quotient without the remainder. So you ignore the remainder. Okay? So you just say y equals whatever the quotient is, x plus 1. That's your slant asymptote. So that would be this, like a slanted dotted line that you would graph. And so then your graph kind of hugs that. You use that to sort of help be more accurate with your graph. Okay? So again, that's going to happen when the power is greater in the numerator. Okay? All right, so let's have you try practice 3A. So find those asymptotes. And then we're going to start graphing it. So let's see how far you can go on the graph. All right, so Andres, what is the denominator? Well, let's start with horizontal. What's the horizontal asymptote, if any, for this one?
I'm stuck.
Okay, so this is one that you do it in your head. There's nothing to really write down for this. So you compare the powers. So the power in the numerator is 1 because it's 2x to the first, right? So the degree is 1. In the denominator, the degree is 2. The highest exponent is 2. So you're comparing 1 to 2. So if the denominator wins, what does that mean? What's the horizontal asymptote?
Doesn't it mean like 0?
Yes, it's y equals 0. Okay? So you want to write HA y equals 0. Horizontal asymptote is y equals 0 because the denominator has the highest power.
Wait, I thought. Oh wait. Okay. There we go.
So that's the horizontal asymptote. Now, when you factor, nothing cancels. Okay? So that means no whole. All right? So then, Caitlin, what would be the vertical asymptotes for this? So now I don't want you to just say 3, but say x equals 3. X equals 3 and there's one more.
X equals 2.
X equals negative 2.
Okay.
Because see, it's what makes these go to 0. See, when you factor and you set it equal to 0, then it's x equals 3 and x equals negative 2. Okay? So, and no holes because no factors cancel. So now when you put it together, you start where you're graphing those lines. Okay, so y equals 0, that's along the x-axis. And then x equals 3, vertical line through 3, x equals negative 2, vertical line through negative 2. Okay, now, in order to graph this, what you need is 1 point. Okay? You just need 1 point to get started. So usually what I do is I will graph, I'll plug in 0 for x. Okay, if all the x's go to 0, then you end up with negative 1 over negative 6, which is 1/6. So when x is 0, you get a point up here above the horizontal asymptote. And so what that means is, I mean, I don't have it exactly, but it's going to go like this. So it doesn't cross the horizontal asymptotes or the vertical asymptotes usually. Okay, and so then, unless a factor occurs more than once, it's going to flip. So if it goes up on this side of the horizontal, of the vertical asymptote, if it goes up, then it's going to come down. It'll go down here. So I don't know why I didn't draw that, but so it'll be down to here. So at the vertical asymptote it flips. So then this one's going to go up, and then it goes up again, and then it flips, and so this side will go down, and then approach the horizontal asymptote. Now, if you're ever not sure, then just put it in your calculator, and you can get the general look of it. What the calculator does not graph, though, are the asymptotes. So those I would want you to graph on your own. And so that's why I asked you to find those first, is to graph those vertical and horizontal asymptotes. And they won't appear on your calculator. Okay. All right, any questions on that? All right, so now do practice 3B. So the asymptotes and the holes. So you've got to, well, I'll just be quiet. See if you can do it. Okay, so let's see what we've got. Okay, so usually I start with the horizontal asymptotes. So can anyone tell me what the horizontal asymptote is?
Y equals 1.
Yep, that's it. Because the powers tie, so it's y equals a over b. So 1 over 1, so y equals 1. Okay? Then you factor everything to see if, to get the vertical asymptotes and the whole. Okay? So x plus 4, that cancels. So that means there's going to be a whole at x equals what?
-4.
-4. Okay? And then this other factor, x plus 5, produces a vertical asymptote at x equals
-5.
-5. Okay? All right, so the domain is all real numbers except -5 and -4. But x equals -4 produces a whole because that factor cancels. And then you have your vertical asymptote at -5, your horizontal asymptote at y equals 1. Okay, here, let's move. Let's see. Okay. So, any questions on that? Actually, do that one first. All right. So, to graph the rational functions, okay, number one is factor the denominator. So, you determine the domain from that. So whatever makes the denominator go to 0, that's not going to be on your graph. It's either going to be a whole or a vertical asymptote. Number 2, you factor the numerator. And so that says determine the wholes. So any factor that occurs in both the numerator and the denominator is going to cause a whole. Okay, number 3, find the vertical asymptote. So whatever didn't cause the whole, that's going to be your vertical asymptote. Okay, step 4, find the horizontal or slant asymptotes, and you do that by comparing the powers. Now, if you 5 and 6 are if necessary. If you need to find points, usually the easiest ones to find are the intercepts. So to find the y-intercept, you plug in 0 for x. To find the x-intercept, you plug in 0 for y. But you only have to solve for the numerator because the denominator can't be 0. And then finally you graph. Okay? So, okay, so it says if the, now, so practice 4A and 4B. I'm going to just have you do that before class tomorrow and just see if there's any questions that you have on it. You can check it using your calculator, okay? But I particularly am interested in asymptotes and then intercepts if you need them, okay? Now, if the numerator has no solution, then there are no x-intercepts. So like for this, if I want to know, well, what's the x-intercept for this? Well, see, the numerator can never be 0. So if the numerator can't be 0, then that means it can't have an x-intercept. So it does not cross the x-axis. All right. So I'm going to jump to the last bit of notes here, solving rational inequalities. Okay, and the reason why it's in this section is because a lot of the things that you do are going to be the same. You find the zeros of the numerator, find the zeros of the denominator, and plot these zeros on a number line. Determine if each interval is plus or minus, interpret the answer. So this is, we did this line test when we were solving polynomial quadratics. So hopefully you'll, once we do an example, you'll remember that. All right, anybody need any more time on this? Okay. All right. So let's do this practice 5 here together. So to solve something like this is kind of, you have to have it set equal to 0 here. So you're going to need to move the 3 to the other side. Now, to get a numerator and denominator, what we have to do next is to combine those together. So we have to get a common denominator. So if there's no denominator, it's assumed to be 1. So what would be our least common denominator here?
X plus 2.
X plus 2. So we're going to have to multiply numerator and denominator of the second one by x plus 2 so that we get a common denominator. And so now we can put them together over that denominator. So here I'm distributing the -3 through the parentheses. and then combining like terms. Now, I can't, even if I factor out a 2, or -2, nothing's going to cancel there. Okay? All right? So now what I look for are the zeros of the numerator and the denominator. So the 0 of the numerator, set the numerator equal to 0, and I get -3. And then the 0 of the denominator is -2. Okay? So now the 0 means that's the 0, the U means that's where it's undefined. So now I take a number in each of these intervals and see if it's positive or negative. So like, let's say if I plug in -10 in here. So -10, -2 times -10, that'd be 20 minus 6, that'd be positive over negative. So that's negative. So you don't really care what the number is. All you care about is the sign.